Hi everyone, welcome back to the channel. Rolling coin, this is quite a tough problem, and it may be beyond the scope of some of the engineering entrance examinations like IIT JEE in India and GOK China or even Olympiad. But solving this problem gives a lot of insights into the concepts of angular momentum and rigid body dynamics. And this will definitely help in tackling some of the problems that students get in some of these entrance examinations or competitive examinations. So, my goal is to solve this problem, but at the same time, impart some of the concepts which are very important, key to solving some of the complex and tough problems in different examinations at different level. Before we start, if you want to give it a try, then please go ahead and do that. And let me know your solutions, or if you have any questions and queries, you can send me email or you can leave a comment. Okay, the way I approach these kind of problems is by following some of these steps. First, we need to get the logical understanding of what's going on. And there you must spend 10 second, 20 second, 30 second, or even more if it requires to understand what's going on. Then draw the free body diagram. Choose the axes which are convenient for writing the equations. Then write the equations and then solve those equations. Today, we are going to follow the same steps. But at the same time, there are few concepts that we also must understand very, very clearly. And let me start with some of those concepts today. Okay. So when it comes to angular momentum, we need to understand that the angular velocity is a vector and it has a direction which follows the typical thumb rule. Angular momentum follows the same direction as angular velocity. And it is because angular momentum is nothing but I omega. And if angular momentum we are writing in some direction, let's say x, then I is also in the direction of x. And omega is of course in the direction of x too. Now what is torque? So torque is nothing but rate of change of angular momentum. So this is defined as dl by dt. So this is basic concept that we must remember while solving these kind of problems. Now let's actually define some axis here. Okay. So let's say this is our, let's call this y-axis, and let's call this direction as x. If this coin is rotating with smaller omega, let's say in counterclockwise, then this is also going to follow this circle in this direction. Right? And let's call this bigger omega, and this is what we are supposed to figure out. Okay. Now it's given that the coin rolls without slipping, which means that the distance that is covered by the coin on the surface, on the ground, is equal to the segment that is being swept on this circle. We can write big omega r should be equal to omega r. Now, if you're not able to see this, then let's understand this way. So in this circle, let's say the coin, let's say this is a coin, and it rolls a little bit in the counterclockwise direction, and it covers this much distance. Okay. And let's take this angle as alpha. This is the same segment that is also being covered on the bigger circle that this coin is following. And let's call this angle phi. So the length of this segment should be exactly equal if you compute from this coin perspective or from this bigger circle perspective. So what is the length of this segment? Let's call this A prime. Then A prime is phi into bigger r, because this is r. This segment is theta into r or phi into r, and it is also equal to alpha into small r, right? And if you just differentiate this, so d phi by dt r equal to d alpha by dt r, and therefore what we get is r equal to small omega r. Okay, so from here we get the small omega as bigger omega r by r. Since we need to find bigger omega, so we will just use this expression whenever we have to use small omega. Let's draw a free body diagram for the coin. So let's say that this is the coin. Okay, we are just viewing it from the side, and this is the circular path that it's following. So we have a weight which is acting here, let's say mg, and since it is moving in a circular path here, let's say like this, with omega, bigger omega, so there is a centrifugal force which is m omega square r prime, and r prime is nothing but this distance r prime. Therefore we can write r prime as, if you see, this one is theta and this is r, so r prime is nothing but r minus small r cos theta. Okay, so now if you see, there is a torque now because of these two forces. If we compute the torque at this point, let's say point P, which is the point of contact, then, and we already have also described this one as Z. So the torque will act in the Z direction. If you see, because of mg, there is a torque in this direction, which is positive side of Z, this direction Z. And because of this force m omega square r prime, the torque is actually into the paper on the negative side of Z. mg, the distance is r cos theta, this distance, minus, because of this, the torque is in negative Z direction, m omega square r minus r cos theta, and then the distance, this distance is r sin theta. So then this is r sin theta. Okay, and this is the torque that we have in the positive Z direction. So let's mark this as the equation 1. So this torque must be also equal to the change in angular momentum here, because there is an angular momentum, and we must match the torque because of angular momentum in Z direction with this because of weight and the centripetal force. So now let's see how do we write the angular momentum. Now this is very important for us to understand. So let me draw the picture again. Okay, so let's say this is the disc or coin. Now let's, instead of using xy, let's use the principal axis of the coin. So principal axis is typically the axis passing through the center and the other rotational direction. So let's say this one is I and this one is J. Okay, now we know that this is going in counterclockwise, so omega is acting in this direction, right? If you use the thumb rule, you will get omega in this direction. And then we also have the bigger omega in this direction, right? Okay, this angle is theta because this is theta, right? So let's write the expression for angular momentum vector. Okay, let's see how it looks like. L is actually Li in the I direction plus Lj in the J direction. This is as simple as that. Now what is Li? We know that L is I omega, right? We can write this as I in the I direction and omega I, so this is, and then Ij omega J to J direction. Okay, this is my angular momentum vector. What is I? So this is moment of inertia in the I direction, which is half mr square. And what is Ij? Moment of inertia in J direction, that is 1 by 4 mr square. Now can we write omega I? So if you see omega I, let's see omega I. Omega I is omega in the I direction, so one is minus omega because it's in negative I direction, and plus component projection of this bigger omega in the I direction, which is omega cos theta, right? And omega j, so the projection for this smaller omega in j direction is 0. So only the projection of bigger omega in the j direction, which is omega sine theta. So now we can rewrite L as 1 by 2 mr square minus omega r by r plus omega cos theta. I just used this expression and replaced omega with this expression. In I direction, plus 1 by 4 mr square and omega sine theta, and this is in j direction. Okay, so this is the angular momentum vector. Now we need to compute the torque in the z direction. So in order to compute the torque in z direction, we need to consider the angular momentum in x direction and the y direction, because they can apply the torque in the z direction. Okay, now let's consider the angular momentum in x direction. So angular momentum in x direction is nothing but the projection of this L in the x direction, which is, this is x direction and this is y direction, right? Now, if you see angular momentum y, it is just rotating in the circle, bigger circle. So the change in angular momentum is 0. So which means that there is no torque because of Ly. So if you see here, Ly is simply like this. This is Ly. If I project this L vector in the y direction, and this is just circulating in this horizontal circle. So the Ly is not changing, which means dly by dt is 0. So dly by dt is 0. So there is no torque because of Ly. But Lx, if you see, on the other hand, Lx is in this direction and it is rotating like this. So although the actual value of Lx is not changing, but the direction of Lx is changing, which means Lx is changing. Therefore, dlx by dt is not 0. So how do we compute dlx by dt? So let's see. So let's say that at any moment, at this particular moment when we are considering, this is the Lx. Now after some time, the Lx will go in this direction, like it will move through an angle, let's say delta phi, okay? And this is the delta L, delta Lx. This is perpendicular. Now if you see, first of all, the delta L is perpendicular to the Lx. So which means if Lx is in x direction, delta x is going to be in the minus z direction. Okay. So delta x is in minus z direction. And what is torque? So torque is nothing but change in rate of change in angular momentum. So let's say delta t when delta t tends to 0. Okay. What is delta x? Delta x is nothing but Lx into delta phi, right? Because this is the angle through which the Lx has turned, and delta t, and that will become Lx d phi by dt. Therefore, the torque in z direction, this is in z direction, in this direction, because, or you can say this direction, which is like negative z, right? Because delta x is perpendicular to x. So hence torque z is Lx into bigger omega. Okay. So this part should be clear. Now this is because delta Lx is perpendicular to Lx, and that is negative z direction. Okay. So now let's write this equation as well. So we can have another torque z because of this change in rate of change in the angular momentum, and that would be minus Lx omega, minus because it's in the negative z direction. Okay. So what is the projection of L in the x direction? So this is the I. So this whole thing into sine theta. So we'll take that half mr square cos theta minus r by r, and then sine theta. And then we have z direction, we have this one. So there is a component for z in minus x. So that will be minus 1 by 4 mr square mean sine theta. And then this angle is theta again. So cos theta. Now the direction of this is in the minus z direction. So we need to add a negative. Okay. Therefore, this whole thing is 1 by 4 mr square. We should not forget the bigger omega here. Okay, so let's take this as common. Sine theta cos theta, okay, minus 2 sine theta cos theta and plus 2r by r sine theta, right? Therefore, this is 1 by 4 mr square omega square 2r by r sine theta minus sine theta cos theta. Okay, so let's call it equation 2, and this torque should be equal to this torque. So we just need to equate these two equations. So let's do that. So from 1 and 2, we can just we have mgr cos theta minus omega square r minus r cos theta this is equal to this whole thing. So let's just simplify this. Mgr cos theta should be equal to, we can take mr square omega square by 4 as common. So this will become 2r by r sine theta minus sine theta cos theta, okay, plus r minus r cos theta sine theta 4 by r, because we have taken 4 here and we have also taken r square outside. Okay, so then this is equal to mr square omega square by 4 2r by r sine theta minus sine theta cos theta plus 4r by r sine theta minus 4 sine theta cos theta. Okay, so we'll just simplify further. mr square omega square by 4. This and this will become 6r by r sine theta, and the rest is minus 5 sine theta cos theta. Okay, so we can simply just take the cos theta outside. So mr square omega square, and also we take the 4r and cos theta. So then it becomes 6r tan theta minus 5 sin theta. Okay, and here if we have mg r cos theta, so this whole thing will simply cancel out m also, and therefore we can write omega square as 4g divided by 6r tan theta minus 5 sin theta. We should not forget the r. Okay. And that's the expression for the omega square. Okay. For omega to be positive, so first thing is this denominator cannot be 0 and it should be greater than 0. So 6r tan theta minus 5r sin theta should be greater than 0. That means r should be greater than 5 by 6 r cos theta. Okay. This is the condition. And that's the answer. So let's analyze what happens if theta tends to pi by 2. So let's say theta tends to pi by 2, which means the coin is rolling vertically. So if you see tan theta becomes infinite and therefore the omega tends to 0, which is perfectly understandable because now the coin is rolling vertically and it's going in the straight line. So there is no circular motion, hence the bigger omega is 0, right? And for theta, when it tends to 0, so the coin is now getting flatter and flatter. And then we see that omega tends to infinity. And this is also clear because if coin is flatter, then we need very high angular velocity in the positive y direction in order to maintain that motion. So this seems fine. I hope you enjoyed this session and you learned quite a few concepts here. Thanks for watching. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.